Hi everyone, in the previous class we have seen how to construct mod 6 up counter, right? Now in this class we'll go with the mod 6 down counter. Means basically we can able to construct the down counters or up counters if they are the powers of 2 directly, right? But if they are not the powers of 2, we are going to have a problem. I mean, if I am going to have 2 bits, I can able to construct mod 4 counter. 2 flops I can able to construct mod 4 counter. If I am going to have 3 flops, I can able to construct mod 8 counter. But here it is not a kind of powers of 2, right? So I hope you know the reason why I am trying to say it is powers of 2, right? Yes. So here if you would like to construct the mod 6 down counter, you have to have some kind of logic changes. That logic you already understood if you watched the earlier video, right? Yes. So now what I would like to convey here na, so if I am going to start with 7 6 5 4 3 2 and next again it has to come back. This is what mod 6 down counter, right? So 7 6 5 4 3 2. If it is mod 6 up counter, what is going to happen? 0 1 2 3 4 and 5, and then again it go for, this is what mod 6 up counter, and this is mod 6 down counter, right? So in the earlier case what we did na, whenever we are going to get the outputs as 110 or 111, we made the clears as 0, clear as 0. Now also we'll follow the same logic. I mean, we can go with the same other kind of logic, right? So first of all, if you want to have any kind of down counter, first the logic is you have to connect the bottom Q0 bar with this one. Am I right? I don't want to go with all writing everything. So J0, K0, and let me go anyway. Let me go with all these things, right? This will be the 1, right? Now the situation is it will be acted as now down counter. It will act as down counter. So anyway it is going to start with 7, but the point is, see, if I am going to have the clock, with QC, QB and QA, 0 1 2 3 4 5 6 7, it will be 111 110 6, then 5, right? 101, then 4, then 3, then 2, and then 1, then 000. But here the simple solution is, when you reach to this particular point, you have to move back. That's it. You have to move back, right? In that you have to avoid these two cases. Again, you can able to get the unique data, right? So when QC and QB values are 0, you can able to simply do something. So what I can do now? So earlier, you know, there are some kind of preset state is there for every kind of flip flop. Yes, preset state is there. Similarly, clear also there. But now what you will use, right? So when you are going to reach to 111 to 010, what you have to use? If I use clear equal to 0, meaning that by doing some kind of equation, if I made the clear equal to 0, what will happen? Next output you are going to get as 000, but next output you need to get the 000 or you need to get the 111. You need to get the 111, not the 000. So to get the 111 as output, what might be combination you have to use in asynchronous JK flip-flop, right? So if you remember the earlier one, in the active low state, preset, clear and Q state should be, right? So if you want to have the preset state should be 1, preset is 0 and clear should be 1. Then this particular combination you can able to get as 1, right? So for that reason, what we can do now, you can make use of this combination. I'm going to use separately this combination as 1. As 1. At what situation you have to make them as 1? Or you have to make them as 1, or you have to make them as 0. You have to make them as 0. And clear value you have to make them as 1. See, I need to get the value 1. You have to make the clear value as 0, and you have to make this value as 0, right? So to make the value 0, if I take one NAND gate, so here you need to have 0. You need to have 0. So suppose for example if it is 0, what might be this entire inputs values? This entire inputs value should be QC bar and QB bar. This is QC and this is QB. That's it. So means for this particular case, definitely this is going to produce the values as like mod 6 down counter. This is J2 and K2, J1 and K1. Right? Again you may get question, right? How you got, right? This is a kind of a combination. Right? This combination is unique over this entire data. That's why I have taken this directly. Right? See, observe, if I am going to have QC value as, what is QC? That is produced by this one. What is QB? That is produced by this one. What is QA? That is produced by this one, right? You know already these are going to be taken at the outsides. Right? This QC is 0, its complement is 1. QB is 0, its complement is 1. 1 and 1 is 1, and its complement is now 0. Right? When it is 0 and clear is 1, irrespective of JK flip-flop clock signal or JK flip-flop inputs, it is going to always produce the value 1. That's the reason it will work as per the given requirement. Right? So if you want to solve it through again a kind of diagram, you can go with those K maps. Right? I hope it understood clearly. Thank you.